Here we wish to simplify a radical that has a variable under it, and that variable is of an even power. So very, very special case. We're also going to assume that the variables are positive. Okay, so we're going to use a concept here that essentially we know what the square root of a perfect square is, right? Those things are designed to cancel each other out. So in that first example, let's put a little bit of extra detail into this one, but then I'll just show you the shortcut, is that when you want to do the square root of w to the 18th, well, w to the 18th is w to the 9 quantity squared. So the nice thing about having an even power under the radical is that every even power is something being squared. So if you have the square root of something being squared, those cancel and leaves you with just the expression w to the 9th. So the shortcut that you can use is that since you have 18 copies of w under the radical, and they all kind of pair up when you're doing a square root, that means the copies of w left after you simplify the radical is going to be half as many copies of w. So what's half of 18? That's 9. So why don't you pause the video and see if you can do the second two. And assuming you tried the second two on your own here, I'm going to put in the answers. For this one, we have the square root of u to the 16th. So there's our u. And using the shortcut, what is half of 16? Well, half of 16 is 8. So there's your final answer. And for the last one, well, that's a y to the 24th under the radical. So our answer is going to have a y. And what is half of 24? Well, half of 24 is 12. So there's the final answer for that one.